Okay, let's look at page 2 of the mock exam for unit circle core. First we're going to do number 4. And on this one it says to draw one angle on the unit circle with a sine of -1. What would be its reference angle? Okay, so there's a couple ways you could do this. One is to use the fact that remember that any point on the unit circle, any red point on the unit circle, has as its coordinates the cosine of the angle which connects it to the origin, comma, the sine of the angle which connects to the origin, which is, it sounds kind of hard to understand, but let's draw it. I think it's a little bit easier. Okay, so let's say that I have a point right here. Okay, if I have a point right here, the x-coordinate and the y-coordinate of this point, since it's on the unit circle, the x-coordinate and the y-coordinate of the points are going to correspond to the cosine and sine of the angle theta here. Okay, now what it's doing is it's asking us to draw a special angle on this unit circle with a sine of -1. Okay, so basically what they're saying is that the y-coordinate of the coordinate pair of the point we're going to draw in green, is something comma -1. Well, did you know that basically there's only a couple points, 4 points actually, on the unit circle that reach a 1 value in the x-coordinate or the y-coordinate, and it's these 4 points here, right? That's the only time you ever get an x-coordinate or a y-coordinate of 1 or -1, because every other point it's like, it's too far away from the x-coordinate of 1, -1, or the y-coordinate of 1, -1. Okay? So which one of these would have a y-coordinate of -1? Well, that has to be this point here, right? Only this point, which is 0, comma, -1, has a y-coordinate of -1. So basically the reference angle here the angle here would be, as you can see, 180, 270 would be 270 degrees, right? What's the reference angle for 270 degrees? Well, it's the amount that it went past 180 degrees, or is missing to get, it's like the amount that it's like lacking to get to 360 degrees. Either way, 270 minus 180 is 90. 360 minus 270 is also 90. So the reference angle here is going to be 90 degrees. Okay? All right. Moving on to number 5. Draw two different angles on this unit circle with a cosine of -0.707. What would be their reference angle? Okay. First, I'm just going to draw it, like as an estimate. Okay. So remember that if it has a cosine of -0.75, basically we're saying, okay, points on the triangle that have an x-coordinate of 0.707 and a y-coordinate that's unknown. Okay. So you can see that this is the y-coordinate of -1, right? So -0.707 would be about here, right? So -0.707, there's 2 points on the circle with an x-coordinate of -0.707, which would be these 2 points here, right? These 2 open circles are showing the 2 possible points with an x-coordinate of -0.707. That's why there's 2 different angles. So I'm going to sketch these 2 angles here. This is one of the angles. This is the other angle. What would be their reference angle? Well, it turns out that if you have an x-coordinate of -0.707, then go back up here to the table. Where do we see -0.707? Oh yeah, when we have a 45-degree triangle, both the sine and the cosine of are 0.707. So when we have a x-coordinate or y-coordinate that is 0.707, we know that the size of the other leg of the right triangle is also 0.707. So like, for example, in this case, the x-coordinate is 0.707, so the y-coordinate also should be 0.707. Now, we have a positive 0.707 for the top triangle, and we have a negative 0.707 for the bottom triangle. So the 2 possibilities are -0.707, positive 0.707, or -0.707, -0.707. Okay? What would be their reference angle? Well, we know that these are 45, 45, 90 triangles, so the reference angle would be 45 degrees. Okay? All right. Last 2 problems. Number 6. Draw 2 angles on the unit circle with a tangent of -0.577. Okay, what would be its reference angle? Okay, draw two angles on the unit circle with a tangent of negative 0.577. Let's go back and see when the tangent of an angle equals 0.577. Oh, it happens at 30 degrees. So whatever triangles we're going to draw, they have reference angles of 30 degrees. So let's use pink for this, since we used pink to highlight the table. And so basically what we're saying is the tangent of 30 degrees is 0.577. So we're going to draw this is a reference angle, right? We're going to draw all the triangles that have reference angles of 30 degrees. Well, the easiest one is the 30-degree triangle that's in the first quadrant, right? There's 30 degrees right there. But remember, we can flip this triangle around to here, to here, and to here. And these triangles all have reference angles of 30 degrees because they all have 30 degrees between their hypotenuses and the x-axis. So like this angle, this angle, this angle, and this angle, they're all 30-degree angles. Okay? So it says draw two angles on the circle with a tangent of negative 0.577. It's two of these triangles. Which ones are they? Okay? So remember, tangent is a ratio that is opposite over adjacent. So the opposite is, remember, I'm going to draw it like in green here. So the opposite is the vertical coordinate of these triangles because it's the side that's opposite from the origin. And then the adjacent is the horizontal sides. Okay? So the adjacent is the horizontal side. The opposite is the vertical sides. And in which cases do we have positive or negative green or orange sides? Okay, now we can see that the green side here is positive because it goes up. The green side here is also positive because it goes up. The green side here is negative because it goes down, and the green side here is negative because it goes down. What about the orange sides? The orange side here is positive because it goes to the right, positive because it goes to the right. The orange side here is negative because it goes left, and the orange side here is negative because it goes to the left, right? And so now we're going to look at these, and we're going to find when the tangent is negative, because we want negative 0.577, not positive 0.577. So which of these combinations would give a negative number? Well, when we have, this one has positive divided by positive, because it's green positive divided by orange positive, and they're both positive, so that gives you a positive number. The one over here, we have a green positive number on top and an orange positive number on the bottom. Hey, that gives us a negative number. So this is one of the winners right here. Okay? What about here? We have a negative green number on top. We have a negative orange number on the bottom, which gives us a positive number. Negative divided by negative gives us positive. So this is also not an answer. And then finally, in the fourth quadrant, we have the green negative number on top and the orange positive number on the bottom. So the result is a negative number. So this is our other winner. Okay? So we know that the reference angles for every one of these triangles is 30 degrees, right? So if we wanted to figure out what are the angles in this case that have a tangent of negative 0.577, it would be this angle here, and it would be another angle which goes all the way around to here. Those would be the two angles, the pink angle and the blue angle, okay? But basically, we already know that the reference angles, we drew the two angles, so I'm gonna maybe erase the angles that are not correct. So like, I'm gonna erase this one because it's not correct. I'm gonna erase this one because it's not correct. And now we have the two triangles remaining that have a tangent of negative 0.577. Okay? What would be its reference angle? The reference angle would be 30 degrees, right? Okay. Number 7. Write down an expression in terms of pi which calculates the arc length of the bold area. Okay, so the bold area is this whole thing right here. But the arc length of the bold area would be just the outside part, right? The arc length would be this part here. So Now, some people were confused by the fact that it says area here and it says arc length here. The bold area means that the area that's outlined in bold, but the arc length would be just the outside of it, okay? So basically, we're going to take the circumference formula, which is written on the first page, circumference equals 2 pi r, and we're going to multiply it by the amount of the 360 degree angle that we're looking at. So it would be 270 degree angle divided by 360 degree angle. That's the fraction of 2 pi r that we want. And then we just need to figure out, okay, what's the radius in this case? The radius is 10 miles. And so we just put 10 in for r. And so that would be 270 divided by 360 is actually 3/4. And 2 pi r is 20 pi. And if you want to simplify it, it would be 60 divided by 4 times pi, 15 pi. But I would accept, any of these two, okay? Or even this. 15 pi is the answer. Okay? And that's it for page 2.